So thank you. It's been a long day. I'm impressed this many people are still in the room after how long a series of talks this has been. I'll try to make this a little bit slower and a little bit more interesting than I might normally. So get your blood moving a little bit. So I want to talk about what essentially OpenDaylight has been doing in the last release, which is Beryllium. And I'm going to talk about the major changes we've had, as well as sort of what OpenDaylight does and what you can use it for. So I think the single biggest thing that's changed in the last 6 months in OpenDaylight has been users. We just have we finally have a really substantial user population who can actually give us feedback about what it is that we should be doing and what it is that they want out of OpenDaylight. And I'm going to start with some results from our users. I think there's been a lot of people talking about how OpenDaylight is only for service providers, or OpenDaylight is only for data centers, or OpenDaylight is only for research and education networks. Our experience, the data we have actually says that pretty much everybody uses OpenDaylight. And they use it in different ways and for different purposes, but we have lots of service provider customers, we have lots of enterprise customers, we have lots of data center customers. And I'll talk about some specific examples a little bit later on. It also isn't all one particular kind of customer. We have people in a whole range of different industries, ranging from energy to finance to telcos to everything else. And it doesn't really correlate by size either. Really, everybody of all different kinds are using OpenDaylight. Geographically, we also are really pleased with the distribution. In particular, you'll see that 30% of our users are in Asia. Most of those are in China. So we actually have a substantial number of people using OpenDaylight here, and I'm sure more of you know than I do. And this is really exactly what we want. And a big effort that we're currently going through is to try to unify our different communities. Right now, we sort of have 2 or 3 different split communities between the US, Europe, and Asia, and trying to unify them and actually get a single cohesive community which can exchange ideas and share information is absolutely critical. And we're doing our absolute best as we can. If you're interested in how to participate, please reach out. You can find me pretty easily, but figuring out ways to deal with the time zone and language barriers has been interesting and hard, but we're working on it. And you can also see here, there's more about how much things have shifted. We're seeing a huge number more people actually using or testing OpenDaylight. In this bottom graph, you can see we've gone from about just over 60% of people actually using it or testing it to nearly everybody that was responding was actually trying to use it or test it today. And so this is just the biggest shift is that we have real users who are actually trying to do things. This is an eye chart. Don't worry about understanding everything that's on it, but it gives you some idea of the breadth of components we have available in OpenDaylight. I've colored the yellow items as the new things in OpenDaylight. So you can see that we've introduced a variety of new different pieces. In particular, we added a NetIDE component, which was designed to do controller compatibility. So you can run other controllers' applications on top of OpenDaylight as long as they use OpenFlow. So you can run Flowlight applications or even ONOS applications on top of OpenDaylight if you want to, by translating the OpenFlow to OpenFlow. We added message buses to the side, so you can plug in other applications, not just OpenDaylight applications, using standard message buses, things like XMPP or AMQP. We have new features for analytics, so that way you can fold OpenDaylight into the broader ecosystem of your organization. We realize that OpenDaylight cannot be everything for everybody. And we have a bunch of other sort of new applications in the space of security, which is what Controller Shield does, additional applications in policy. We have additional applications in terms of providing network virtualization, Fabric as a Service, FaaS is there, as well as some applications for cable providers, UNI Manager, as well as additional protocols we have support for OFconfig. So if you're using OFconfig, we now have the models for that in OpenDaylight as well. So there's a bunch of new features, but you can also see just the really wide array of other things that we've had from previous releases. So hand in hand with having real users and getting this to actually work, the biggest thing we've heard people ask for is performance, scale, and stability. This is what happens when you need things to actually work in production. People care about performance, they care about whether or not it's widely available, and they care about how it scales. And so we've spent a huge amount of time working on this, including enhancing our clustering and high availability to extend to all of the core protocols, including netconf, OBSDP, and OpenFlow, as well as adding support for faster VNFs through integration with DPDK, and just a massive amount of testing about how things work and how often they work. And the culmination of this has actually been a performance report. This is a white paper you can go download if you want to. The URL is at the bottom. And this was looking at real network scenarios using 2 or 3 different test environments, comparing to other controllers for if you're interested in how performance compares. And also, all of the tests are publicly available code. So if you want to run the tests yourself, you can go download them and run them in order to compare them to our results. And so we also have recommendations about what we've experienced in terms of performance and what changes performance and what doesn't. Just a few highlights from this. Our OpenFlow REST programming rates typically run about something like 2,000 flows per second without batching. If you use batching, we can get up to about 10,000 flows per second. This compares, roughly on par with what Floodlight and Onos achieve using REST OpenFlow programming. Onos has recently added batching as well, and they get similar performance when they use batching. So they have about 10,000 flows per second with batch flows. And you can see, if you're more curious about a specific scenario, we tested if your network rebooted and all of the flows need to be reinstalled. So all the flows are already in the controller, but they need to be installed on the switches. And we see restoration rates somewhere in the realm of 10 to 20,000 flows per second. So this is testing the southbound performance more than the northbound performance. And we see similar performance to the other controllers. This appears to be sort of more a limitation of switches than limitations of the controllers. There's a whole bunch more information here if you're curious about our performance. You can see performance results for more OpenFlow, netconf, OBSDP, BGP, PSEP. And we have other advice for how it is that you can run OpenDaylight. The biggest thing that we discovered was OpenDaylight uses persistence by default. And as a consequence, it benefits heavily from using solid-state disks or SSDs. And so if you're going to use persistence in OpenDaylight, make sure to have a fast disk, preferably a solid-state disk. That results in almost an order of magnitude performance difference in our experience. And beyond the performance report, every single patch that is ever checked into OpenDaylight in the relevant projects is checked for performance regressions. So this is a live graph. It's not from today, but of the flow setup times and flow setup rates for OpenDaylight on each individual patch. So every time somebody makes a change to the code, we run all of the tests for performance, and so we know if we've ever broken our performance, and we understand that it's staying reliable and it's actually going up and to the right. So before I talk about sort of what our users were asking for, what they needed, and in terms of performance and scale, but they're also asking for features. And so one of the things, the dominant use cases for OpenDaylight, certainly not the only one, has always been OpenStack integration and network virtualization. And the biggest problem we've had has always been closing the gap with the Neutron default ML2 plugin, the one that uses Open vSwitch. And so in Beryllium, we actually have closed the gap. Every feature available in the standard OpenStack ML2 plugin also is now available in OpenDaylight, including distributed L3 forwarding, as well as load balancers, the load balancer as a service, firewall as a service, VPN as a service. We also have, and so we now have a complete end-to-end Neutron solution, and it scales better and is a little bit faster than the alternatives. We also have support for a bunch of things that you can't find most other places, including support for hardware virtual tunnel endpoints, so hardware VTEPs, so that way you can terminate your OpenStack for network virtualization connections in hardware. This is really useful for gateways and connecting to the rest of the world. And we have additional support for L3 VPNs, which we are hearing a lot from carriers. And there's new blueprints in OpenStack if you're curious to go look at that. Along with having more users has been basically lots of tooling that goes around OpenDaylight. So SDN controllers don't exist in a vacuum. They have to integrate with the rest of your ecosystem and the rest of your software. And so we're seeing additional toolkits to allow fancier visualizations. So the Next UI toolkit provides a substantial improvement in terms of how fancy diagrams you can draw and topologies. We have tooling for things like NetIDE that lets legacy SDN applications for things like Ryu, POX, and similar tools to run on top of OpenDaylight. And so the result is you can port your own applications. We have additional time series data repository, TSDR, and analytics tools that let you plug it into your broader ecosystem of applications and your OSS and BSS. So this is really all about OpenDaylight avoiding being a single point that can't integrate with the rest of your system. We understand that OpenDaylight needs to be part of a broader IT ecosystem. These are the beginnings of those tools, and we're working on more as we move along. This is just an example of how the NetIDE application works. It actually speaks OpenFlow. So basically you have an application that runs, it emulates it by running the older controller, then translate that to OpenFlow, feeds OpenFlow down to OpenDaylight, and then OpenDaylight can translate it down into your network. So you can run legacy applications on top of OpenDaylight. So the last thing I wanted to end by talking about, and these are probably the most interesting results from our user study, which is what do people actually use OpenDaylight for? And we sort of classify this into 5 different categories. We have 3 brownfield deployment techniques and sort of 2 greenfield deployments. And we divided them into automated service delivery, network resource optimization, visibility and control, cloud and NFV, and research and education through government networks. And these are not use cases that we made up as OpenDaylight. These are, when we asked users what are they actually doing with OpenDaylight, this is the bins that sort of fell out from what they told us. And the only one here that might be surprising is we lump cloud and NFV together. And most people talk about them as sort of 2 different things. Our experience has been that NFV is a superset of cloud. So everything you have to solve to get cloud to work, network virtualization, and integration with compute and storage, you also have to do to make NFV work. But in addition, you have to get the fine-grained forwarding and service chaining to work, which is harder and more complicated than just cloud. So NFV is really a superset of cloud. So the first use case that we've seen is automated service delivery. And this is essentially, think of self-service portals or the ability to deliver new services to customers quickly. And we've seen this from a bunch of different users. AT&T delivers their bandwidth on demand service in this way. Telstra is delivering data center interconnects in this way. And we're seeing the large data provider deliver data dissemination in this way. So providing new and interesting services that they couldn't have provided before to their customers quickly and easily. And this is something where OpenDaylight's ability to control multiple different devices using multiple different protocols has been absolutely key. So we're seeing a lot of instances here where it's not just OpenDaylight, but there might be multiple different controllers. So maybe integrating one controller for OpenFlow with a different controller for the rest of the network. And at the bottom, you can see a link to go OpenDaylight.org/user stories. If you're interested, we have all of these posted. You can read more about them there. There's a whole page on every single one of these people. So AT&T, Sarah Solutions, Telstra will each have their own page. The second major use case we're seeing is network resource optimization. This is really about taking the resources you already have and the services you're already offering and making better or more intelligent use of your network resources. And we're seeing largely major users use this in order to optimize essentially their resource usage and their costs. Tencent has probably done some of the most interesting stuff here with using OpenDaylight to run their data center interconnects and optimize how they use bandwidth in between them. And I'm sure that you can find out more about that here than I can. But we're seeing this as many, many different times. How you pick the optimal path, how you do rate limiting, how you do quality of service management, and efficiently use the network resources you already have. The third major use case we're seeing is visibility and control. And this is really, I like to talk about it as your starter home for SDN. It's what is the first, simplest, and easiest thing you can do in order to try and get your toes wet with SDN? And the answer is almost always a little bit of monitoring, so that way you can tell what's going on in your network, you can get the topology more easily, or possibly just a little bit of control and automation. Can I automate, provisioning VLANs easily with a script instead of doing it, using logging into 10 different boxes? And we're seeing a lot of different people use this. And interestingly, this is one of the places where we're seeing success in applications. So I also work at Brocade, and our Flow Optimizer application lets users do exactly this, which is to be able to get visibility into what flows are right across their network and install rules to handle certain events. And we're actually seeing a lot of success in that being sold as an application on top of OpenDaylight. This has been probably one of the first examples of a particularly successful single application as opposed to sort of a complete distribution on top of OpenDaylight. So that's really the brownfield different deployments. The last two are sort of greenfield, which is what could you do if you reimagined your network from the ground up as SDN oriented? And so the biggest use case we're seeing here is cloud and NFV. And this is how do you provide networking services to a data center, in particular a multi-tenant data center, and oftentimes a multi-tenant data center where VMs are providing network services themselves. That would be NFV. And we're seeing a whole bunch of proofs of concept here, including China Mobile, Orange, and the Massachusetts Open Cloud has been doing a whole bunch of academic testing in the US. And this is sort of the Uber use case for all of OpenDaylight. It's using every last piece that we have available, including picking paths, doing network virtualization, service chaining, integration with OpenStack to provide DNFs. And so this is really where the breadth of things that are available becomes critical, because this is more than just one use case, one protocol. This is inherently multi-protocol, lots of different moving pieces. And lastly, and this is interesting, OpenDaylight actually has support for Internet of Things devices. We support the COPE protocol and the M2M specifications. And if you combine that with network telemetry and being able to gather statistics and lay out flows, we're seeing adoption of OpenDaylight as sort of a unifying operating system for smart cities and universities and research institutions. And so this is doing a variety of really interesting stuff, anywhere from running the city of Bristol to trying to use it as a platform to provide research data quickly. And we're seeing, again, OpenDaylight's breadth of different capabilities and the ability to bundle them together quickly being sort of the key differentiating factor as we explore that. And so this is sort of really exciting, and I think that seeing OpenDaylight engage in sort of China Mobile doing NFV and providing part of 5G services, and also expanding Internet of Things makes me really excited, just because those are the future of what networking is going to be, and OpenDaylight is already there participating. I'm going to skip this. One last thing. And the number one complaint we hear about OpenDaylight whenever I talk to people is documentation. We are taking documentation very, very seriously at this point. We have our Java documentation APIs online. Here are the three URLs for the core documentation. We're in the process of porting the documentation from PDFs to HTML, where it can be translated more easily. And we just recently engaged with SDN Lab in China in order to provide Chinese language tutorials and other resources. In fact, just this morning I was looking at, there is a Q&A site on SDN Lab's page, which is taking questions in Chinese and getting answers. So you can go to that resource. It's really cool. I wish I could answer more questions, and maybe I'll try through Google Translate. But anyway, if you want to get started, we have a brand new Getting Started guide in addition to the normal documentation. You go to opendaylight.org/start. It will tell you how to download, run, and get started with OpenDaylight and the different projects that are available and what you might be able to do. So I'll just leave you with that, and thank you so much, and hopefully you guys will get to lunch soon.